Vaisakhi. Good evening. You all have not submitted your assignments. Many people have not submitted. Please submit the assignments on time. Okay. Uh, okay. So today we are going to do. I'm going to show you classification algorithms, and after that we are going to do we have a Power BI, or you can do a visualization. If you want, if you know Tableau, you can do it in Tableau as well. Okay. And we are going to do a classification algorithm. So let me show you multiple two or three classification algorithms. After that, we do a data set for classification of breast cancer. So let's see. You can see my screen.
Yes.
Okay. So in the last sessions we have done regression in which the data is divided into two parts. One is X, another is Y, where X are the features, single feature or multiple features, and Y is the target variable. But here in regression, the only thing you need to keep in mind that Y is always a continuous numeric variable. It's a number. That means you are trying to predict a sales volume or price, or a marks, something which is related to a number. While in classification is also supervised learning, it's also a supervised learning algorithm where the data set is divided into two parts, X and Y, where X is the features and Y is the target variable which you want to predict. But here the target variable is always either a categorical variable. That means we are trying to divide the data into groups or classes. That means we are going to label them into classes. Like for example, a group of rows, I'm labeling them as these are the customers who are defaulters, or these are the customers who are non-defaulters. These are the customers who are eligible for loan, and these are the customers who are not, these rows are not eligible for loan. So we are kind of labeling them, okay, with the help of a target variable. So Y always need to be a categorical variable, or it can be as well as a number, but number has to be like a discrete numeric variable where your number is behaving like a label or a categorical variable. Okay, so that kind of thing can happen. For example, risk. If the target variable is risk is 1 means it's high, 2 means it's medium, and 3 means it's low. So we are trying to determine if the rows are customers are in the high risk zone or medium risk zone or low risk zone. So in that case, 1, 2, 3 are again, they are not, they cannot be considered as a continuous numeric variable, and we cannot do regression with that. Instead, though it is a number, it is a discrete numeric variable, so it will be like behave like a categorical variable. So this you need to understand. Okay, so the when we have categorical variable, we do not have any other suspicion or ambiguity, because we know that for sure it's classification. But when we have a number, you may think that okay, we can do regression also, but then see that is it a continuous numeric variable or a discrete numeric variable. If you are not sure, you can plot a distribution plot to check the distribution. That distribution, the histogram will show if there are intervals or breaks in between the data. That will, from that you can understand it's a continuous numeric variable or discrete numeric variable. Because sometimes if it's an integer also, it can be a continuous numeric variable. Okay, like age, year, these are all integers. They are not floats, but then also they are not count, they are measured. So what is the difference between a discrete and a continuous numeric variable? A continuous numerical variable is always measured. A discrete numeric variable is counted. Okay, so that is the difference between a continuous and a discrete numeric variable. So I hope you have understood it. So we are going to judge the data set based on that. Based on that, you can understand that what you need to do with the data set, whether you want to do classification or regression with the data set. So we are looking at a very common, easy algorithm, which is called k-nearest neighbor. Let's first see the use cases of classification, that what are the cases or what are the different scenarios in which we will do classification. I hope everybody is following here. Okay. So here, first example which we have is this loan application form. Okay, so in previous days we used to have the loan application form filled up manually by the customers, and then approval. Like there are some people from the bank who used to check their background, do a background checking, and then uh, like approve the loans. But later on nowadays it's a like we have kind of targeted marketing, and the loan whether a customer is eligible for loan is already first it is calculated the customer is eligible for a loan or not, and then the customer is called. Okay, the customer doesn't have to walk in. Basically the customer who is eligible is called. So that is called targeted marketing, and that has been possible because of machine learning. And here from in the so we have data sets like this, and because we already have some previous data, because from years loan application approval has been done manually, so we already have data. So we have to take the data with the loan id, gender, the different the customer demographics, like the gender, whether he's married or not, how many dependents does he have, what is the education, whether he's self-employed. Okay, so what is the what is the income of the customer, what is the co-applicant's income, and so on. And after that, we have this target variable y. So always understand in classification, because it's supervised learning, the data should consist of X and Y. So predicted data, the data which you want to predict, should already be included in the data set. This label should exist. If it doesn't exist, that means you can't do supervised learning. Supervised learning is something that I need to have the data with the customer's loan approval, loan status known. That means I should know that this is the data of the row of the customer, and this customer was approved a loan or not. That I need to know. Okay, so that data I should already have, because from that the system will learn the pattern. So I have data, for example, I have 200 customers record, and I have the data of the customers along with their loan status, whether they have been approved a loan or rejected a loan. With this I can train a model or a machine learning model to predict new customers. Okay, so if we are going to do this, which is the cancer detection of tumor, and in which we have this ID. So now understand that in any whenever we are doing any kind of analysis, the analytics data doesn't require ID, because something which is unique does not give any pattern to us, doesn't give any advantage in analysis. So we can just safely discard the ID. So here diagnosis is the target variable, and these are the features. And the features include radius mean, texture mean, perimeter, area mean, smoothness, and so on. Okay, so these are the data, and this is the diagnosis is the target variable. Okay, so now we also have this data set. So I have given examples of multiple data sets. Once you see the loan approval data set, here the loan status is the target variable, or Y. Then I have the cancer detection data set, where the diagnosis is the target variable, or Y. And then I have this data set of iris. Iris is a flower. These data is being collected manually by scientists. That means the flowers, the size of the flowers, like the length of the sepal. Sepal is the green part which is attached to the flower petal. That is called the sepal. The length of the sepal, the width of the sepal, the length of the petal, the width of the petal, as well as the species. So species here can be the target variable because it's categorical variable, you can see, and we can take it as a target variable. Now you may ask me that what about sepal length? Can I predict sepal length? Can I predict sepal length of superven? That means I will take sepal length as y and the rest as x. Yes, you can do that. But in that case, sepal length, when you are taking it as a y, what kind of algorithm should we do for that? Should it be a classification? Because y is a, if in case sepal length is y, it is y is continuous numeric variable. In that case, what kind of algorithm should we use? Should we use classification? Now tell me this. If I want to predict sepal length from this data, what kind of algorithm will we use? Should we use classification, or what other algorithm we should use? Tell me the answer in the chat. If I want to predict sepal length, so for me x becomes like here, x is equal to sepal width, petal length, petal width, species, and y is sepal length. So what kind of algorithm should I do? What do you think? Yeah. So regression, yes, correct. So when we are talking about both x and y, definitely it is supervised learning, because supervised learning only has both x and y. When I'm talking about both x and y, and I'm saying x is equal to sepal width, petal width, and species equal to sepal length. In that case, y I need to predict sepal length. In that case, x and y, so it's supervised learning and it's regression. Okay, because y is a continuous numeric variable. But if I am taking x is equal to sepal length, sepal width, petal length, petal width, and y is equal to species. So y here is a, again it's supervised learning, but y here is a categorical variable. So this will be classification. Have you understood the difference between classification and regression? So this is the most common. Now when you go for the interview, the most common question they ask is, what is supervised learning? What is unsupervised learning? And what is the difference between classification and regression? This is a very basic question, and people, like, they are students study a lot of questions. They study what is decision tree, what is parametric, what is deterministic algorithm. So tough things, but they fail to answer these basic questions. So be very careful. This is very basic question. Okay, so you should be knowing this. Okay, next we are talking about this data set is the Titanic data set. Now you can see it has target variable as well as, I'm sorry, it has categorical as well as numeric variables. Now here in this data set, this is a Titanic, that is the passengers who were like they were riding on Titanic, or they were on the Titanic while it drowned. And these are the actual names and gender, age. Okay, so how many siblings they have on board? What is the ticket? What is the fare? whether they have cabin or not, all these things were there. Apart, so here the target variable generally is this survived. Now you can see survived is not a categorical variable, it is a discrete numeric variable. So when you have discrete numeric variable as the target variable as well, we are doing classification. So this is also a classification data set. Okay, but if you decide to take age as the target variable and the rest of them as the you know the features, then this can also become a regression data set. But not all the data sets are meant for all the algorithms. So regression maybe it cannot give you a good accuracy. Okay, some data sets are meant for a particular algorithm. So maybe this data set cannot give you a very good accuracy on the on for predicting age, because for each algorithm the data set need to follow a certain assumptions. Okay, every algorithm comes with it as in certain assumptions which need to be followed for that algorithm. So this is a typical classification algorithm dataset where the target variable is survived, and survived, you can see it is not a continuous, it is not a categorical variable. Okay, it's not a text that you are doing classification, but for discrete numeric variables also you can do classification. Okay, I hope you have understood. So if you have discrete numeric variable or categorical variable, you as a target variable, you can do classification. So let's understand the first very preliminary and very easy algorithm, which is called nearest neighbors classifiers. Means it doesn't have much complicacy. So basic idea is it is on the assumptions. Most of these algorithms are made by, of course, they are made by humans, and they are inspired from natural theories. That means theories which exist in nature. Okay, so here this is also based on a theory which is based on like like we have proverbs, you might have heard that uh, you are like your neighbor, basically. Yeah, basically you are like your company, you behave like your company. If your company is evil, you also can become an evil. If your company is good, you can become good. So this is based on that. So what it says, if it walks like a duck, then probably it's a duck. That means if it is features are similar to a duck, then it is a duck. And what are the features in case of machine learning? The features are the neighbors. That means for a data point in a 3 or 4 dimensional space. Okay, so this is a 3 dimensional space and a data point in a 3 dimensional space. So it has some neighbors. It has some neighbors. Okay, so if these neighbors belong to class C1, so this also should belong to class C1. That is the theory here. Okay, so let's see this. So if you have, so if it is like, if most of its neighbors are ducks, so if you check the distance of this duck or the data from its neighbors, you can see most of its neighbors are duck. There is a hen, but it's far. So most of its nearest neighbors are duck. So this is considered to be a duck. Okay, because in machine learning, the similarity in the features or the closeness is because it is a numeric algorithms or statistical algorithms. It is based on the distance. It is based on the distance of that data point from the other data point. So the distance, this I mean the if this is A and this is B and this is C, okay, so A is closer to B than C. Okay, so A is more similar to B. That is how it is. Have you understood? So if the distance between A and B is lesser than A and C, that means A is more similar to B than C. Is it clear? Okay, so we'll check the similarity. So let's see this algorithm. So given n training vectors, KNN algorithm, so the full form is k nearest neighbors, where k is supposed to be a value. Okay, so k is supposed to be, so k is supposed to be a value. Generally, it is an odd number. We don't take 1 as the neighbor. We take generally 3 as the neighbor because we take a voting. Okay, so among the 3 neighbors, if 2 belong to one class and 1 belong to some other class, that means the data point belongs to the maximum voted class, basically. Okay, so here, given n training vectors, KNN algorithm identifies the k nearest neighbors of C regardless of labels. So now you can see this is C, which is the data point which you are trying to classify. This is the data point which you are trying to classify, or it can be the row which your data point here means the row of the table or the row of the CSV file. Now, so it can be a customer, it can be a project, it can be a animal, whatever it is, whatever is the data set regarding, it can be a disease. So I'm trying to classify something. It can be a tumor. Okay. So here, the C, now you can, if you check the neighbors, it has 3 neighbors, two of its neighbors belong to the class O and one of its neighbors belong to class A. So if I'm considering 3 nearest neighbors, the class of C will be O. The class of C will be O because maximum of its neighbors belong to O. Okay, so that is the theory of k nearest neighbors. So choose an odd value of, for a 2-class problem, k must not be a multiple of the number of classes. So it should take an odd value, because if it is 4, there is a chance that there is a tie. Then what you will do? The main drawback of KNN is the complexity in searching the nearest neighbors of each sample. So I'll just show you how it is done, basically, so that you understand. And this is the KNN classifier. Okay, another thing for KNN is you need to understand, this is also a very good interview question where it is asked that why KNN is called a lazy learner. So there are 2 types of learners in machine learning. One is called a lazy learner, another is called a eager learner. Now, the eager learner is something which is like whenever you're doing the training. Now, what is training? Training means, like we had studied in linear regression algorithm, during the training, the machine, when you are creating the model, the machine creates something called the coefficients. So machine is using some y equal to mx plus c, some formula, and it is creating this coefficient m and c. Once it creates the coefficient during the training, it, during the prediction, what it is doing, it is just using this coefficients and as a substitute and getting the value of y. During prediction, it doesn't have much work. Okay, so once it creates, so during the training phase, it creates this coefficients, and during the prediction phase, it uses this coefficient. So that is called eager learner. That means when you are learning, you have created something, some pattern in your mind. That is, whenever you are giving the test, you just recollect that pattern, and automatically you are able to recreate that situation and answer the scenario. Nothing like that happens during KNN. Okay, in KNN, there are no coefficients which are created. KNN is based on the based on analysis of similarity of patterns. That means it compares the rows and finds similarity. Okay, so that is what is KNN does. And so KNN does not create any coefficient. It every time, whenever it is doing prediction, it is calculating the distance, finding the similarity, and doing the prediction. That's it. It is not creating any coefficient. It has to go through each and every row and check the patterns and find out that which of the 3 neighbors are the nearest. So that is why KNN does not have a training phase. Okay, so there is no advantage of KNN during the prediction phase because it doesn't create anything during the training phase. It is basically calculating the similarity, and the calculations are done during the prediction phase. Okay, so I'll just show you the example of this. Okay, it doesn't learn a discriminative function from the training data but memorizes the training data set instead, there is no training time in KNN. So KNN basically does not have the training phase at all. Okay, so it has only a predict phase. So it is called a lazy learner. So I'll show you how the KNN algorithm works, and you can understand that why it is different from the regression algorithm. And because of that, and there are other algorithms as well, like we are talking about decision tree, which is also a eager learner. Okay, so all these are eager learners. Only KNN is a lazy learner. So the prediction step in KNN is expensive. Each time we want to make a prediction, KNN is searching for the nearest neighbors in the entire training data set. A eager learner has a model fitting or training step. A lazy learner does not have a training phase. So let's see how the KNN algorithm works. I hope everyone is following. Can you write following in the chat, please? Write following here. Okay, here. Anyone else? Good. So now I'm just showing you an Excel sheet here. So you can see this is an Excel sheet and this is the IRIS data set. Okay, I'm just saving this as an Excel sheet. Saving it as an Excel document. Okay, now you can see this is the IRIS data set in which I told you there are three types of flowers in this IRIS. IRIS flower is something you might have seen. So IRIS flower, you can check here. So there are three species of iris flower, and they are the iris flower is distinguished from each other from their uh, length of the petals and the length of the sepals. Okay, so these are the iris flower. Okay, you can see the iris flower has different. They look different. They have different types of species. They look different, and because of the flowers, some of the flowers petal are long, some are short, some of the sepals are long, some are short. Okay, so depending on that, we have different types of species in iris flower. So scientists, botanists have gone to the fields, and they have collected this data, which is like 150 records. We have 150 records, 50 records per species. Okay, now for example, I'm trying to predict. Now this is my actual data, this is the training data, but for prediction I have a test data, and that for test data I'm trying to predict. I'm just writing it here. So this is my let's remove the id is of no use. ID is not used in any kind of analysis as well as for machine learning. So I'm just removing the ID. And then here I am adding the data, like suppose the sepal length, I'm just adding some random data. This is the data, okay, so which I have. And I want to know that what is the species of this data. So I want to know the species. So how do I calculate? I want to know the species of this flower. Okay, so now what, for understanding that, for doing the calculation, I need to know the distance of this flower or of this data point. This is a data point basically. Okay, this is a data point and I need to know the distance of this. So I want to know this, its neighbors. Okay, so who are its neighbors and what is the distance of this data point from its neighbors? That is what is the main principle of KNN. So what I'm going to do, I'm going to calculate the distance. Okay, so I'm calculating the distance. So how do I calculate the distance? There are many ways to calculate the distance. One of the formula is Euclidean distance, which the formula is x minus x1 minus x2 whole square plus y1 minus y2 whole square and we are doing, because we have done square, we'll do a square root of this. So this is one distance formula which is called Euclidean distance, and we also have another distance formula in which instead of squaring and square rooting afterwards, we do an absolute. Okay, so we do a kind of absolute, x1 minus x2. Absolute means we discard the sign, so I do not require the need to square it, plus y1 minus y2. So now let's calculate the distance. So for this, what I'm doing here is equal to, so this is x1. Okay, so here x1 and x2 I'm telling why, because there are only this is a two-dimensional data. How many dimensional data is this? There are 4 columns. So there are 4 columns, so it's a 4-dimensional data. So how will we write here? So I'm doing this one absolute because it is easy to do. Otherwise, I have to use too many functions. So absolute of x1 minus x2. So x1 is this minus length, nice simple length, x2 plus abs y1 minus y2. Okay, plus abs z1 minus z2 plus abs minus, so this. So 5.8 is the distance. Now I am going to copy this formula into the other cells as well. For this I need to make, because I have calculated G, this is G5, right? So this I want to make it constant because it should not change, because this is the constant. These other A2 will change to, instead of A2 it is going to change to A3. B2 will change to B3. So I am not going to change this. This I am going to fix it. So I'm using it's called absolute referencing in Excel. I'm using a dollar sign here. So now I'm just going to copy it. So just now you will see I have got the distances of the distance of this row or this data point from all the other data points. Now I want its neighbor. So I'm going to sort this data. Okay. So I'm going to sort the data. So data sort and sort by, and I'm going to do distance smallest to largest. Okay. So smallest means the smallest distance will come on top, because I want the shortest distance. So three nearest neighbors. So shortest three nearest neighbors are this. Okay, the three nearest neighbors. So here, if I'm saying k is equal to 3, the three nearest neighbors are this. And these, and you can see the species of this, it shows iris versicolor very specifically. Three nearest neighbors shows this is iris versicolor. So this is also iris versicolor. Simple. Now you understand, like this, if I am doing another prediction, what it is doing, again, it is calculating the distance and it is going to shuffle the data set. So for each data point in prediction, it is going to do the same thing. It is going to calculate the distance and shuffle. So there is no training phase. It is not creating any coefficient which is going to reduce the time for the prediction phase. So that is why it is called a lazy learner, because every time it includes calculating the distance and shuffling. So there is no formula, no coefficient, no rules which are created. I hope you've understood why it is called a lazy learner. Why it is called a lazy learner is an important question. Understood? Just right, understood. Okay, now, yeah, that's it. So prediction using KNN. In KNN, you will see that you have to provide the testing set, training set, and the classification vector all at the same time. For most other prediction algorithm, we build the prediction model on the training set in the first step. So this does not have a training phase. Directly we do prediction. So I need the test data set for the prediction. KNN function does both in a single step. So like Euclidean distance calculation. Okay, the next thing which we need to know is the confusion matrix. Okay, so the confusion matrix is used to calculate the matrix. That means what is the correct what is the correct values, how many correct values and how many wrong values. So in case of linear regression, we had a matrix called R2 score, which gives your accuracy. In classification, we have something called a confusion matrix. Now, what is confusion matrix? Now here, for example, so here, yeah, I have taken an unknown data set, but I could have taken anything in this only, which is already there, and could have calculated the prediction. Okay, and so system will give me a prediction. Now system is always not 100% correct. So some of the predictions are correct, some of the predictions are wrong. So I already know the species. Now here, this is a species which is saying iris versicolor, but when we predict using a system, it says Setosa. Okay, so it says Setosa or Virginica. So there is a mismatch, right? So based on that, we are creating the confusion matrix. So let's see the confusion matrix and how a confusion matrix, how to understand a confusion matrix. Okay, so let us consider. So in many cases, classification algorithms are used for disease prediction in health analytics. So we'll see one of the tests. So consider that we have done a test of dengue for the patients, and I have 5 patients. 1, 2, 3, 4, and 5. So P1, P2, P3, P4, and P5. So these are my 5 patients, and this is my actual test, and this is predicted test. Okay, so one is actually you have gone and done a test of dengue. Another is you have done it with the help of machine data, and the machine has given some prediction. So here consider, so we are talking about the data. And for patient 1, actual says that he has dengue. Prediction also says he has dengue. Okay. Now, for patient P2, actual says he has dengue. Prediction says he doesn't have dengue. Then for patient P3, actual says he doesn't have dengue. Prediction says he has dengue. Next, patient P4, actual says he doesn't have dengue. Prediction says he doesn't have dengue. And P3, uh, actual says that he doesn't have dengue. Prediction says he has dengue. So these are the conditions which are and based on that we have scenarios. Okay, so we have 4 type of scenarios. Uh, yeah. So first is actual says yes, he has dengue. The prediction also says actual says the test is positive. Prediction also says the test is positive. So this is called true positive. True positive. Next for P2. Now this matrix is I mean, it is followed by all the classification algorithm. Whatever is the classification algorithm, the matrix will be the measurement will be this only. This is the only measurement which is available. Okay. Next for P2, actual says the patient has dengue, but prediction says the patient doesn't have dengue. Okay. So it doesn't have dengue. So it says it is negative, right? So prediction says it's negative, actual says it's positive, so it's called false negative. False negative. Okay. Next, actual says he has dengue. He doesn't have dengue. Prediction says he has dengue. That means false positive. Actual says he doesn't have dengue. Prediction says he doesn't have dengue. That means true negative. And actual says he doesn't have dengue. Prediction says he has dengue. False positive. So there are 4 cases: true positive, false negative, false positive, true negative. There are 4 cases here. Okay. Now this thing we can write with the help of a confusion matrix. Now see the confusion matrix here. So this is a square matrix in which we have 4 quadrants, in which this is the, for example, this is the actual and this is the prediction. Okay. So 0, 1, 0, 1. So this is actual, this is prediction. Okay. Now 0, 0 means actually 0, prediction is 0. Okay. So 0, 0, how many rows are there? Only 1, I can see. So I'm writing 1 here. Next is 0, 1. So that means this. Actual 0, but prediction says 1. There are 2 rows here. Next, 1, 0. Actual is 1, but prediction is 0, which is false negative. There is 1 of this record. Next is 1, 1. Actual is also dengue, prediction also says dengue. So this all makes 5, 2 plus 1 plus 1, 3 plus 4 plus 5. Okay. So this is the confusion matrix in which 0, 0 is the true negative, 0, 1 is the false positive, 1, 0 is false negative, and 1, 1 is true positive. Okay. So here we have multiple metrics here. One is called the accuracy score. Accuracy score will only consider the diagonal. So accuracy. Accuracy means mostly we do this only. The diagonal means true positive plus false, true positive plus true negative. divided by all the data. That means 2 divided by 5. That means here 40%, 0.4 or 40% is the accuracy score. But apart from accuracy score, there are 4 other metrics also. Okay. Have you understood this? So I'll tell you other metrics also. So this theory is also very important. I think for confusion metrics, I have a separate slide. Just give me a second. Great. Here. Yeah, if you are giving 1 here and 0, I have given 0 here and 1 here. If you give 1 here and 0 here, the matrix will become like this. What I did was I gave a 0 here and 1 down. So I delete it. Okay, I did some diagram right here. Okay, I don't know why did I delete it. Anyway, so if you write instead of 0 here and 1 here, if you write 1 and 0 here, this will be the matrix. I mean, true negative, instead of true negative, true positive will come here. So it doesn't make difference. You can do it in any way. It's fine. So these are the components. True positive, the predicted value matches the actual value. True negative, the predicted value matches the actual value. The actual value was negative and model predicted was negative. And here the actual value was positive, model predicted a positive value. Types of errors, 2 types of error, false positive, which is called type 1 error, false negative, which is a type 2 error. The predicted value was falsely predicted, actual value was negative, but the model predicted a positive value. For false negative, the predicted value was falsely predicted, actual value was positive, model predicted a negative value. Next, we have this called precision. Okay, so precision means that now precision here is a see you have this confusion matrix, right? And I have, if you write 1 0 1 0 here, this will become true positive. This is become 1 0. 0 is negative, so false negative. 0 1 is false positive, and this is true negative. This is your confusion matrix. Okay, now I am saying I told you the accuracy score is true positive plus true negative divided by all the values. So that is the accuracy score. That means we are only considering the diagonals. But here I am paying more attention to the false positives, because false positive here plays in this scenario. False positive will make a very critical kind of error. There are scenarios where false positive is more important than false negative. Okay, so here the formula of, then we are calculating precision. Precision is true positive. True positive means total number of positives divided by total number of positives, actual positives divided by total number of positives given by the system. So true positive plus false positive. So this is, so true positive here, I think in this case, false positive was 2. 0 1 was 2. Okay, so then precision will fall. Okay, if your true positive is 1 and true positive is 1 and false positive is 2, so it is becoming 1 by 3. That means 0.33. That means your precision will fall down. There, the accuracy score was 40%, but precision is 33, means the model has a model has a high rate of false positive. That means your precision has gone down. High precision means the model has low rate of false positive. It predicts something is positive, very likely to be correct. So, filtering content for children, you want to ensure that a video classified as safe for kids is indeed safe. Okay, so it should, in case it is giving false positive, that means it is not safe, but still it is safe, showing as safe. In that case, this is very critical for, so the precision is important to calculate here, not only accuracy. Okay, because accuracy is focusing only on the true positive and true negative. It is not focusing on the false positive, on the error. So here, minimizing the risk of showing a violent video to a child, high precision is crucial. So here we want the model to be a high precision model because we don't want false positives here. Next, we also have recall, where false negative is a very crucial. False negative is something when you have a disease, but the machine says you don't have a disease. So it's basically, in case of a disease, it's very critical because you go untreated and you think that you don't have a disease and you go untreated, and that may cause a more critical situation. So here, true positive, here also, and actual positive divided by actual positives in the system. So true positive plus false negative. False negatives are actually positive because that's why they're given as negative. So true positives plus false negatives are the actual positives in the system. So that gives you, if the false negatives increases, your recall false. It correctly identifies most of the actual positive cases. Use case diagnosing a rare disease. You want to ensure that you identify as many actual cases of the disease as possible. Next is, we want to pay attention to both precision and recall. In that case, we calculate harmonic mean. So harmonic mean is defined as a reciprocal of arithmetic mean of the reciprocals of the observations. So you can see this is called F1 score and it's calculated like this: 2 multiplied by precision multiplied by recall divided by precision plus recall. Okay, so this takes into account both precision and recall, and so it's a better way to look at the score by F1 score. Okay, we also have something called specificity and sensitivity, and with the help of that, we are calculating something called the ROC curve, this curve. So this also will look later. Before that, let's do this also I will show you after I do the practical. So let's do a practical here very quickly. Jupyter notebook. we are going to download a data set, or I'll just upload it from my data set. Okay, the breast cancer data set. Many are you have are doing with Jupyter Notebook? Just write how many of you have logged into laptop. Just write laptop here in the chat. You can just count. So I'm doing a classification of breast cancer. Okay, I did not upload the data set for you, right? So I'll just okay, I've uploaded it here. You can check it out. Okay. Yes, import the data set. Import k neighbors classifier. Just give me a second. K neighbors, n is capital. Okay, this grid search CV is it's a technique which is used for selection of M. Okay, sorry, K here. Selection technique so that we can check, we can get the best value of K. You can take K as 3, but you do not know whether 3 is the best value or not. So in that case, we are using the grid search CV. So here, first I'm showing you using normal, like without grid search CV as you are doing for the first time. So df equal to, first time import the data set. How many of you are actually doing or imported the data set? Just write imported, or Jupyter notebook or your laptop, whatever you want. You just write that you are doing the practical. Okay, one. That's it, right? Okay. All right. So first I'm importing this data set, df equal to pd dot read underscore csv, and you can download the data set and you can copy the path. So first I'm dropping the ID. So I'm just dropping the ID. After this is the diagnosis. So I'm dividing my data into X and Y, and X here, there is no data pre-processing to be done because everything is a number. And diagnosis D, this is the target variable. So this is Y. So I'm just writing Y is equal to DF diagnosis. DF dot drop diagnosis. D is small. Next, I'm splitting the data into train, test, split. Okay, so I'm dividing the data into train and test data. So train data is the data with which you are doing the training. Testing is the part of the data which you are not showing to the model during the training, and you are asking unpredicted questions for prediction with the test data, and you are going to calculate the accuracy of the model. Okay, so split this, we did it during the regression also. Split the data into train and test, and we are writing xtr is similar to regression. Most of these algorithms are similar, so why, if you understand one code, you will be able to do the rest. Train, test, split, x comma y, test underscore size equal to 0.2. Okay, train, test, split not defined. You have to import this train, test, split. Also, you can import confusion matrix from sklearn dot matrix. Import confusion matrix. This part is done. Have you done till this? Let's complete this. I'm just getting water. Okay. So next what we are doing here, we calculate the model, create the model. Model equal to K neighbors classifier. Okay. In neighbors, so this is going as a hyperparameter equal to 3. Dot fit. Actually, dot fit here we don't give. I mean, there is no nothing like fit. It is actually fit predict. So here you can fine and write fit xtr y neighbors. Okay, so you have to check with the X. It says none. That means there is a missing value. I did not check for the missing values here. Okay, so let's see. I think there is a missing column. Yeah, this column you need to down. You need to delete. This column has missing value, so I have to delete this. So delete this from DF. I'm just doing from the beginning because we give go and error. Post Yeah. So now you will see this model. N neighbors is 3. So metric is Minkowski is a type of distance algorithm. Okay. So we were talking about Euclidean and Manhattans. We talked about two algorithms, Euclidean and Manhattan. This is another algorithm. So you can write actually if you want Euclidean algorithm. So you instead of Minkowski, you can write metric equal to. So you can do a hyperparameter tuning. This is called hyperparameter tuning. Metric equal to Euclidean, or you can write Manhattan. Manhattan is that absolute thing. Okay, Euclidean is where we are doing squaring and spreading. Now we will check the parameters. So we have changed this. Okay. Now this is means we have taken the default value as 3. We have not checked that is 3 is the best value or not. Okay. So I'm just showing you how it works. This one. So then we are doing the prediction. That is, we can have two types of prediction. One is prediction when you are using the training data set only, because you have trained with the help of like you have learned from a question bank, you've learned from a book, and you are giving answers from the questions from the book. Okay, when your test paper is also made from questions from the book, so you have an advantage over there. Now you have learned from a book, but your questions are coming from outside the book, similar question but outside the book, so you are actually giving test on the test. So we have two types of prediction. One is p-train, which is prediction on the trained data set itself. So we are telling this model dot predict. Just give me a second. So model dot predict text here. Next is p-test. Model dot predict test. So these are the two. Okay. Next, you can do a confusion matrix. Okay. Apart from, you can print a confusion matrix also. It is taking so much time because it's very slow. It doesn't have a training phase. It doesn't do anything during this phase apart from initializing this matrix. Actual work it is doing during the prediction. So you can print a confusion matrix for either of them. Print confusion matrix, and you can check YTR, PTR. Now you can see this. So what is the accuracy? 286 plus 153 divided by, so it is like 286. You can just calculate manually. Plus 153 divided by 286 plus 153 plus 4 plus 12. 96%, which is good, not bad. Okay, for the test, let's see what about the test data set. So print confusion matrix, Y test, P test. So this is also looks good, which is 63 plus 41 divided by 63 plus 41 plus 4 plus 6. This is a slightly lower than train. Okay, but it's fine. It's also not bad. Okay, now do we always have to calculate it manually? No, there is a there is a report called classification report which you can get from here. So you can just print the classification report, print classification, write print compulsory. Okay, classification report Y test P test. Okay, now you can see here it shows me 91 accuracy. We had calculated this accuracy. Okay, it shows me the precision, recall, everything for both the data, both the classes B and M. We have a benign, malignant. So here it shows me balanced. Now, sometimes what happens, there are more, if you check the target, like if you check here, PF diagnosis, value counts. If you do this, now sometimes we have imbalanced class. This is not very imbalanced. It's 357 and 212, so almost equal. Sometimes for example, the malignant is just 100 and the benign is 400. In that case, there is an imbalance. So in this case also, there is an imbalance of the precision recall also. So one precision is showing as 96%, another is showing 67%. So then we have other measures also to do the balancing act, basically. Okay, so you have understood this. So next thing I want to show you is I want to also show you this grid search CV, which is also an important thing here. But before doing that, I want to also show you this, which is also a very important matrix, which is called the ROC. Okay, so let's see this matrix. So F1 score also you have understood, it's already there here. We have two other types of metrics. We call it true negative rate and true positive rate. Okay, so true negative rate, we call it specificity. These are two different type of metrics. Now we had already learned a set of metrics called accuracy, recall, precision, and F1 score. These are the four sets of metrics which are coming from the confusion matrix. Okay, so now I am talking about two different set of metrics which are coming from another diagram, which we call it as ROC, or receiving operating graph. Okay, receivers operating characteristics curve. Okay, ROC curve it is called. So that is also a very important metrics in case of many of the real life problems. They don't ask for confusion matrix and precision recall, they ask for that ROC. Okay, ROC is based on the probability, because here when you are another thing is when you're calculating the P, here it is giving you specific class, but you can also get the probability, because always the class these are all probabilistic algorithms which can give you the probability. Okay, so anyways, let me tell you what is specificity. So true negative rate it is called. That means true negative divided by true negative plus false positive. So true negative divided by total number of negatives. Total number of negatives are true negative. False positives are also actually negatives. So that is called true negative rate. We have done one, and false true positive rate is the recall. Okay. So you can see this is when we talk about recall. The recall is actually what is recall? Recall is true positive rate. True positive divided by true positive plus false negative. Okay, and this is the specificity is the true negative rate. True negative divided by true negative plus false positive. So recall is also called sensitivity. So these two metrics, specificity and sensitivity make up this curve, which is called ROC. Now, so true positive rate. Now, if we subtract 1 from true positive rate, we get false positive rate. So here you can see this. Okay. So you can see this true positive rate sensitivity we are getting from here, and we are subtracting 1 minus true negative rate, which gives us false positive rate. 1 minus specificity, false positive. Now understand a curve in which in x and y, x has false positive rate and y has true positive rate. Now what I want, both are positive. We are talking about a positive. Now what we want, true positive rate should increase and false positive rate should decrease. Okay. So we are asking the ideal condition of this graph is your false positive rate is 0 and true positive rate is 100, and the graph will consist of, and we can, when this is here, the graph consists of the entire area. So this comes under area under curve. We call it AUC. So when your true positive rate is coming to be 0, when your true positive rate is coming to be 100, true positive rate is here and false positive rate is near 0. Suppose false positive rate is here. So then what happens? Your curve is like this. So here, your curve is like this. So you are getting an area under curve almost 97%, which is good. Okay, so this is considered to be good. If your false positive rate is high, it is here, somewhere here. So if your false positive rate is high, suppose your true positive rate is somewhere here, true positive rate. Actually, it is this one is 100, okay? And your false positive rate, this should be 0, but it is here, somewhere here, which is around 50. So your area under curve will be like this, which is this. So how much area is covered? It is around, for example, 57%, which is bad. Okay, so like this, for example, here the false positive rate is around 0.25. The true positive rate is around 0.75. So your area under curve is 0.6773. Have you understood this? So this AUROC is also very, very important. Okay, let's print the AUROC. Have you understood? Following, just write following in the chat. That will be helpful. Calculating the AUROC, what you need to know first is you have to import the from sklearn.metrics import ROC underscore AUC underscore store. Instead of getting the P test, you have to get the probability. Probability of the I mean, instead of getting the prediction as malignant, you should have the probability of that row becoming malignant. Okay, so that probability you need. So for that, we have this function. Okay, the name of the model here is model, right? So model dot predict underscore pro bar, and you write X test. This is the second. I've done this code before, just a few days before. I'll show it. I did it for this competition. Yeah, this code is okay. So after that, we are what we are doing here: FPR, TPR, and threshold. Okay, these are the three things. So, and you are going to write from sklearn ROC underscore curve. Yeah. Okay. So you are writing FPR means false positive rate, TPR, and threshold. These are the three things, and we are getting ROC. Okay. Y and P. FPR, TPR. Right now we do not require threshold, so I'm just not taking it. And here I am saying ROC of, and here we are taking Y test, P test, robot. Okay, so Y test probe is actually a array which consists of two dimensional data. I mean two columns. I need only one column from here. Okay, either of this. So you can just write Right. It's not coming in the proper syntax. Be the first column, okay? So number of rows remains the same, and here we are writing first column. So this is the first column, but it doesn't show like first column. Dot shape. Let's see. Yeah, that's fine. It is only one dimension. What is the issue with this here? Y takes the value B and PO is level either Y takes the value. Okay. So here basically this probability, no? And we have not changed the value of y into 0 and 1 because we have taken it as a diagnosis. So to do this specifically, you need to change the value of y. So what we are doing here, we have to change the model. Okay. So what you need to do here, calculate the y again. So y equal to, so y is right now like this. Okay. So now I have to change the value of y. Y equal to y dot map and change the value. So, m, which is malignant, we put it as 1, and benign, which is non-malignant, we put it as 0. Yeah. So this y, once it is done, you have to obviously you have to do train test again, split again, because now the entire thing got changed. And you have to create the model also again. So this is done. You can check model 1. Okay, I want predict proba. Oh, this one. Model 1 dot predict proba. Yeah. So This. It came. Okay. No error. Now we are going to just print the ROC curve, which is this. Okay. This is for calculating the AUC. Okay, ROC AUC is AUC. You can see AUC, ROC AUC. We have imported this ROC AUC score. Okay, this is AUC. There is another AUC. What happened? Okay. I ran it again, no? Because that Y, once you do it again, it is going to change the value. A second. Run this again. To print AUC, you do 98. See, this score is much better than the previous one. And now we'll just print the ROC curve. So you can see just plt.plot FPR TPR, color is blue. This can do this. Okay, for this you need to import matplotlib. Import mat. ROC curve is very important because in some cases they are in the industry when you are doing, they don't ask for the precision. They are more concerned about the ROC curve. Part by part. Aspirant. Like this. Okay, so white color equal to blue. False positive rate. ELT dot Y label positive rate. You should show the percentage also somewhere. So for that you need to use the legend, I think. We use a title here. Label. Label equal to. So use a label here. Here you use label. label equal to AUC. PLT dot legend. Here it shows the label. PLT dot title ROC AUC curve. Yeah, that's it. Okay, so we show, I think, done this. So we change this. Only thing which we change here for ROC curve is we created the probability here, created probability or prediction instead of prediction, actual prediction. And plus we changed this, changed Y from categorical to number. You done? Please write done. Okay. Once it is done, just write done here. Done. Okay. Okay. Let's stop here for today. We are going to do more algorithms and need to do the visualization also as well. Do you have any day free in this week? Like for extra lecture? Saturday maybe?
I'll let you know if we have.
Yeah. Let me know in the WhatsApp. Last week there was lecture, right? Which date it was? Or we didn't have lecture last week? Why I don't have the attendance of last week? Did we have lecture or not?
Ma'am, we did.
We did, right?
Yes.
Where is the attendance? It's not there in my lecture. Present even last week.
Ma'am, last week you even added my name, and in this list it's not there.